Good morning, my dear students. In today's class, we are going to discuss about the Unit 4. The Unit 4 is a tracking radar. The tracking radar is used to find the position of the target and to predict the future position also. A tracking radar system measures the coordinates of the target and provides the data which may be used to determine the target path and to predict the future position. All are only part of available data range, elevation angle, azimuth angle, and Doppler frequency shift can be used to predict the future position. A continuous tracking radar supplies. We have two types of radar. One is a continuous tracking radar. It supplies a continuous tracking data on a particular target. And the second one is a track while scan radar. It supplies a sampled data on a one or more targets. In general, the continuous tracking radar and track while scan radar employs different types of equipment. The antenna pattern commonly employed with the tracking radars is a symmetrical pencil beam in which elevation and azimuth beam widths are approximately equal. However, a simple pencil beam antenna is not suitable for tracking radar unless means are provided for determining the magnitude and direction of target angular position with respect to some reference direction. Usually the axis of the antenna as a reference direction. In these tracking radars, we have two types of mode. First, target should be identified. First, tracking radar identifies the target. This is called a search mode. And whenever it identifies the target, then it will tracks the target. This is called a track mode. There are two types of modes are there. One is search mode. It identifies the target. And second one is tracking mode. If the pencil beam is a very narrow beam and if the volume of the scanning is very large, it will take a very long time to identify the target or locate the target. For this purpose, the tracking radar uses separate search radars and tracking radars. The difference between target position and reference direction is called angle error. The tracking radar attempts to position the antenna to make the angle error is 0. When the angle error is 0, the target is located along the reference direction, that is nothing but a antenna axis. From this you can get what are the coordinates of the target and we can predict the future position of the target. There are various methods there for generating the error signal. There are sequential lobing and conical scanning and monopulse tracking radar. In sequential lobing, it is the one method for obtaining the direction and magnitude of angular error in one coordinate by alternatively switching the antenna beam between two positions. Here in the sequential lobing, the antenna beam is switched between two positions. This is called a lobe switching or sequential switching or sequential lobing. The single antenna beam is switched between two positions to obtain the angle measurement. By observing this waveform, this is the antenna beams of a sequential lobing. The antenna beam is switched between two positions, position 1 and position 2. The difference in amplitude between the voltages obtained with two switched positions is a measure of angular displacement of the target from the switching axis. The sign of difference determines the direction of the antenna must be moved in order to align the switching axis with the direction of the target. That means you can get the angle error, and the sign indicates the in which direction antenna should be moved in order to align the target antenna axis with the target axis. When the voltages in the two switched positions, we have to measure the voltages in first switch position and second switch position. If the voltage difference is there, that means there is a angular error is present, and the direction the sign of the difference determines the direction of the antenna should be moved to make the angular error 0. When the voltages in the two switched positions are equal, the target is on the axis, and the position may be obtained from the axis direction. This is about sequential lobing. In sequential lobing, we are going to use a single antenna beam. It is switched between two positions. Based on the voltages in the two positions, we can measure the angle error. If the two voltages obtained from the two switched positions are equal, that means the target is on the reference axis. Therefore, the position or the coordinates of the target is obtained from the axis direction. This is about today's class. Next class, I am going to discuss about conical scanning. It is extension to the sequential lobing. Thank you very much.